Good morning, everyone. Today's Leetcode challenge. Today's Leetcode challenge is partition array for maximum sum. Given an integer array AR, partition the array into contiguous subarrays of length at most k. After partitioning, each subarray has their value changed to become the maximum value of the subarray. Return the largest sum of the given array after partitioning. Test cases are generated so that the blah blah. Okay. So here what do we have to do? We have to partition this array into sub-arrays of not more than k elements such that after partitioning each subarray, all the values in the subarray are going to be replaced by the maximum value in the subarray. For example, if we consider this as our subarray, so 1, 1, 5 and 7, so this is going to be transformed to the maximum value will replace all the values. Okay, all the values are going to be replaced by the maximum value. So here the maximum value is 15, so we are going to replace 1 by 15, 15 by 15 and 7 by 15. Okay, so just like this. So we have to you know we have to find out the the case in which our sum, I mean sum of all the sub array, makes the maximum. Okay, so we have to find that case and we have to return the maximum. So how we can do it, right? What are the ways we can do? uh, if we talk about the brute force way, so the brute force way is going to be, we will make all the possible sub arrays and then we will calculate the maximum value in all the possible sub arrays and then we'll calculate the sum doing that. Okay, so that can be one way, but it is going to be very time consuming, so we are not going to do that way. What we can do is, what we can do here is, okay, so yeah, we can do here is we can solve this problem using DP. Yeah, absolutely. So what we can do, we are going to be making a function in which we will be passing a particular index in a particular index, right? And that function will evaluate that after considering that particular index as a starting point of a sub array. It will check all the cases. It will pick one element or two, three element. Okay, all the cases until k. Okay, all the, I mean, it is going to check k number of cases for picking one element from that starting point, or it can pick two elements from that starting point, or it can pick eight elements from that starting point, like that way. Okay, so it's going to check all the possible cases it can perform, keeping one thing in mind, that the starting point is going to be I, or whichever element is passed into the function. Okay, the function is going to be passed with a value I, which is going to be the index and all the necessary things. Okay, so such a way, and then it will call a recursive function I plus 1 or I plus 2, some something like that. So yeah, it's going to be a recursive function. So let's jump to the code. So what we are going to be needing here is, first off, we have to declare a function. Here function, and we need an index, we need the array, we need the value of k. What else do we need? I think that's it. So here now we need to declare a temporary maximum. So let's declare a temporary max. So what does this index, this temporary max signify? This temporary max represents the value of the maximum element in the current sub array, current case of sub array. Okay, so for initially we are going to keep it to 0. Okay, what else do we need? We are going to be needing a temporary answer, that is also going to be 0, and then we will be calling a for loop for j in range. Okay, so j is going to be in range of minimum of length of array or I plus k. Okay, so the minimum, whichever comes first, the for loop is going to run till there, and here our temporary max is going to be updated, is going to be max of array j versus t max. So now at this position the maximum value of our sub array is t max, right? Yeah, so here what can we do? We can stop here and call another recursive function, or start another sub array from the next element, or we can keep going until we reach our k, I mean j plus k elements, or until we make a k element sub array. We can do this, right? So at this position what we can do, at this position our temporary answer, or let's make it x is will be equals to t max into j. Okay, so I think j plus 1, it should be, no, it should be j minus I plus 1. Okay, and we have to start it from I. Yeah, it's going to be j minus I plus 1 plus, after starting a new sub array, so we will be calling a recursive function here, and we'll be passing j plus 1 and array and k. Yeah, and our temporary answer will be equals to max of temporary answer comma x. So whichever value is max, the temporary answer is going to store that value. And after completing this, now we can return the maximum output or maximum outcome we got from all the k cases. Okay, so the maximum outcome is going to be stored in this one, and we need maximum, so we are going to return temporary answer here, and we will return simple function of 0 comma array comma k. The values of k is going to be same. Okay, let's try and run this. I'll be giving a brief explanation as well after we submit the code. So you can see we have passed the first 3 test cases. Now it's time to submit it. See if we are able to submit it. So it's still submitting. Yeah, so here we see we have a time limit exceeded error, so we have to make it more efficient. So as you can see, only the I is changing here, so we can definitely use memoization here. So we will be using memoization here. If I memo of I. Okay, and here as well mem of I will be equals to answer, temporary answer, sorry. And we also need to pass this, set it, and have to declare standard procedure of memoization. Now let's see if we pass, if it's running properly. Yeah, it's running properly. Let's try to submit it. Successful submission. Now I'll be explaining line by line here now. So what's happening here? So here, if our array is something, okay, let's consider these elements of the array, okay. So at this position we are passing a value I, that is the current index, and all the things, rest of the things are constants, okay. So let's say we have passed 1 in the place of I, okay. Now what is the function responsible of returning here? The function will check, okay. The function can either, make it a sub array of 1, or it can make a sub array of 2, or it can make a sub array of 3. Depending on the k, it can make k number of sub arrays, okay. And after making those sub arrays, it will, end it and start another sub array after, completing the case, okay. So we'll start another sub array, and it will, make a tree out of it, and it will return us the best case, or the case in which the sum is coming the maximum, okay. So that's what this function is responsible for. So as you can see here we are running this for loop till, this for loop for the number of sub arrays, for if, for example, if j is equals to I, in that case our sub array will be of 1, length 1. And for for j is equals to I plus 2, our sub array is going to be of length 2, and we are going to be starting another sub array here. So here you can see we are, making the maximum element here. We are making our maximum element into the number of elements in the array, and we are adding it with another recursive function, and that function will be responsible of returning the same thing from this position, okay. So in this way we are recursively calling our function and getting the answer. I hope you understood. I'll try my best to explain as I can. Okay, thank you for watching.